Good evening, all. My name is Vishwas Kumar. I'm a data scientist trainee at Alma Bitter. Here I come to explain the project I have done on the linear regression model implementation. My project name is Appliances Energy Prediction. Using the regression techniques, I have to implement the appliances energy that on daily basis. Here is the project type is the regression. Uh, Here we contributed this project as a team. My team member name is Sabitendu Mahapratap. Coming to the project summary, here energy is the non-renewable energy. We are mostly using the non-renewable energy nowadays, so it is our duty to use it wisely and to uh, prevent for use it wisely and to utilize it more carefully. So we have IoT system that can predict that can give the data of the every appliances energy consumption and the outside temperatures and humidity. And as well, here that with the use of that data, forecasted data, we have to perform the EDA analysis and have to implement the more linear regression model to predict the uh, accurate results on unseen data. So that can help us IoT system based on the given values. We can cut off the energy consumption. So here is the problem statement and the summary of the project. Here is the GitHub link. Problem statement. We have given the data set of approximately about 4.5 months. The data is collected every 10 minutes within the gap of every 10 minutes using the sensors and all. And the outside temperature is recorded by the Chivers Airport, Belgium. Nearby the airport, the outside pressure and the wind and the visibility and the all data outside the building is being recorded, being collected from the airport database. So that can be help to our analysis. Specifically, the model should be able to reliably anticipate energy usage based on the different elements that influence energy consumption, such as temperature, humidity, and the time of the data, and the month of the data, of course, and the wind speed, and the pressure outside, and the temperature outside. These are all the factors that can be lead to the energies consumption of the appliances in our room or the in our building. So these are come to, so we have to, for starting of the project, we have to import the libraries that are supported by the Python. Actually useful us to load the data and to done the EDA part and the visualization and to implement the model. As we know, import pandas library, NumPy library is there, matplotlib is for visualization, Cbonan is for visualization, and these are all related to the ML statistics. We have to perform the statistics and hypothesis test to derive the which are the important factors that can be lead us to the generating the right model. So here come with the data first. We have mounted the drive, Google Drive. In that, using that Google Drive files, we have uploaded our CSV file so that we can dump the CSV file into our data frame so that we can do the analysis and the understanding of the our variables. Here I defined the appliances data frame. So appliances data frame dot head gives the information about the first 5 rows of the data frame. Here we can see the date that the sensor recorded the consumption and the temperature inside the building and as well as the outside the building. Here we have appliances, lights. T1 is the means T1 RH1 variables. Coming to the data info, info gives the information about the all the columns, rows and column count on the data type of the columns specified in the data frame. We have 19,735 non-null count objects everywhere. So much of the data is about float type. Date is only the object and the appliances lights is the int type. Coming to the shape of the data, we have 19,735 rows and 29 columns, means 29 variables we have. There is no null data is present in the data site. We can get the info. Okay. We come the describe part, describes the all the statistical information about the data. We have the data. The count parts gives the count of the values of the variables. Mean, mean gives the all the mean of the in each individual column. See here the mean of the appliances is the 97, but we have seen max is 1080. The 75% of the data is about 100 kilowatt per hour consumption. This can show there are some outliers within the data, so we have to deal with this. Likewise, which we can see we can see through the visualization later on. So checking the duplicate columns in the data. So we have no on all the columns. Yeah. Here we can show the duplicate columns using the duplicate function that is available in the Python itself. So here shows that 0, 2 means 0 rows are present with the same. We don't have the same type of data recorded in the data frame. So duplicate rows are 0. So we are counting the null values using the isNull.sum function on our data frame. As we said, there is no null objects values present in the data frame. We can visualize through this clear plot using the C1. Here the missing values represented means false, means there is no missing values present in the data. So here comes the final understanding of your entire data frame is that we can conclude that the shape of the data frame and the data which we have collected and the duplicate columns and the missing values here about. So now we can understand the variables, what is means, what is the each column tell sub about the information about the data. So as we know, date, time, the recorded date, appliances, energy consumption in watt per hour, light is also watt per hour. So the T1 temperature in kitchen area. So RH1 means humidity in the kitchen area. So we have kitchen area, living room, laundry room, office room, bathroom. Outside the building, ironing room is there, teenager room is there, parents room is there. So these are the columns T0 that are related to the rooms. We have humidity also. T0 temperature outside, pressure is from the outside, relative humidity outside, wind speed, visibility. So these are random variable one. So checking unique values of each variable. So we have here we define the unique values means function to get the unique values function. So these are unique function gives us the unique values that are presented in the data set. So number of unique column in the date is 90. So every date is the unique column. So okay, 1970-35. So appliances data is 92. Here we can numerically represent the number of unique values present in the data. So here come the data wrangling. So now we created the data frame energy using the appliance. So we cannot, the changes that we may further come does not affect the original data. So we have come up with the copy of the original data frame so that we can manipulate the data and create new data columns and such thing. So we can appropriately, as the way we understand the variables, so we appropriately rename the columns into the appropriate row. T1 as a temperature kitchen. The head gives us the total view of the entire data. So is the same we have done in. So here data, we have to come up some wrangling on the data column so that we can split the date part into the time and the month and the day and the year of the so we can separate the, so we can do the EDA part on different basis, means hourly basis, weekly basis, weekdays and weekends, and month wise we have to calculate, so that we are segregating the date column into the three different parts. Here is the code. So according to that, we have separated some of the few columns rewarding to the same category or the same type of the data. So we are here, temperature columns is there, humidity columns is there, weather columns is there, date columns is there, and random. So we can perform the EDA basis on the columns. So coming to the major part, data visualization, to understanding the EDA part to understand and visualize the data. So here our independent variable is the appliances. So we have to predict the appliances energy consumption over a particular time from the given data. So as we see, the data is more rightly skewed, means the data is right skewed. We have to means for our better linear regression assumption is that it has to follow the normal distribution. So we have to manipulate the we have to some set the data to rectify the skewness of the data to properly to the normal distribution. Here we applied the log transformation so that we can uh, correctly assume that the it's more likely displaying normal distribution. So for the all the temperature columns with the remaining columns also we have to do the check the skewness of the data, so it's following the normal distribution or not. So that will help us to do the linear regression. So on applying all the columns, some of the columns may does not have the here the here the dashed line represents mean and the median of the data. So from that we can clarify that the distribution is followed normal or not. Here so this graph tells about the distribution of the plot. We can see that, and the relation between the dependent variable. As we can see, temperature kitchen is likely following the normal distribution, and the temperature living room is slightly skewed to the right. This laundry room temperature is following normal distribution. This is also following normal. Office room is also normal distribution. So we have to perform the log transformation so that are not actually following the normal distribution. So here we can see the skewness number of the each column that we are in the temperature columns. The skewness number signifies that the value is higher than the +1 is more likely highly skewed to the positive side, means right side. The skewness number which is showing less than 1 -1 is showing us the negatively skewed. The same part can be done the humidity columns and the weather columns also. The skewness number also signifies that. Same here. The random variable ones. Yes, here comes the most important correlation heat map. This is the most important part of the EDA. So here we can see that the entire data set is correlated with how the correlation even between the each one of the variables was the dependent variable. So we can see that the same type of columns present in the temperature, means the temperature The columns is highly correlated with one of each other, and the relative humidity is also highly correlated with the other room temperatures and the humidity. So we have to deal with the temperature columns and humidity columns as well. So we can see that uh, in the correlation matrix is like VIF, variation inflection factor. So we can drive the which are the most influence factor that can be influence the appliances energy consumption. Uh, yeah, we can see the temperature bathroom is correlated with the 0.91 is much correlation with the uh, what do we say? Air humidity teen is highly correlated with the temperature of the ironing room or the temperature of the teen room. So humidity and the temperature are also within the correlation is there. So these correlation may lead data into the overfitting, and we do not have the great regression prediction model. So correlation match for temperature columns. Within the temperature columns means the temperature variable, the temperature kitchen was the living room, the temperature kitchen was the bathroom. So we can see the correlation map between them. Some error is so we can visually see that here temperature columns is there. So this is the appliances with the temperature of ironing room. So how the data is fit into the, so means there is no means linearly correlation with the appliances with the temperature of ironing room. So there are so few columns that are highly correlated with the appliances that can be influence the our model or on predicting the variable more important features. Likewise, humidity is same. The correlation with the appliances, the correlation of the humidity with the appliances. This will give them a number of the correlation. Here, uh, the humidity is also for less correlated with the dependent variable appliances. We can see that with the help of the number and with the help of the visualization also. These are the weather columns means are more likely correlated with the means appliance or dependent variable. Mainly our dependent variable is depend influence the with the outside temperature or the output parameters. You can say. So as we said, we have split the date column into the weekdays and hours. So we can compare the appliances energy consumption or the mean appliances energy over months and the weekdays. So we can see that in every month the appliances is on average is the same, but on weekdays or weekends as the hours also follow the same distribution. Means the Monday Sunday is the more means mean energy consumption is there compared to the others, uh, and the weekends also has the more energy consumption compared to the other days. In coming to the hours part, uh, is more likely to in between 10 to 7, 10 p.m. to 7 a.m. There is less some energy consumption, so we can save the power within those. We can cut the limit. Suddenly, we can save the power. Here we can see the pair plot within the temperature with the other columns distribution. So they have highly correlated or the linear regression. They are highly correlated, and they follow some linear pattern within the data. These are weather columns. So temperature and humidity has negative linear relationship. Temperature and dew point has a positive relationship. Temperature may leads into molecular, as we said. Hypothesis testing. Here I have taken 3 hypothesis statements. Uh, so the first hypothesis statement is there is no change in appliance energy consumption on weekdays and weekend. There is no significant difference in energy consumption for appliances between day and night. Is the second hypothesis statement. The mean temperature in kitchen is greater than the normal temperature. So we can see that there is no change in appliance energy consumption on weekdays and weekends. So here I segregate the data using the weekday and weekday weekend columns using the number 5. So using that t statistics test means the t statistics test compares the uh, test for the mean. So it assumes that the equal variancy, and it is the relation between the two data sets if the means are the same or not. Here that best suited for our hypothesis test. Here the p-value is greater than 0.05, so that there is enough confidence so that we can take our null hypothesis as a true. It comes the mean temperature. Same here. So here the data of every month, first month, second month, third month, we compare the data with the first month, any 2 months, the result would be the same. So here there is means the mean average energy consumption of appliances within every month is same. The p-value state that is about 0.04, so that we can accept the null hypothesis. We come to the feature engineering data processing. Feature engineering means handling missing values. So we are getting ready our data or preparing the data to analysis ready or a model implementation ready for the purpose of model implementation. We are deal with the missing values. There are no missing values. Handling outliers. Outliers is the most important thing to do, because if they have many outliers, the model will fit into overfitting. So that will lead us to the less accuracy result for the models. So as visualization, with visualization, the help of visualization, we can box plot. We can see the outliers in each every column. So in every column there are so many outliers. So we have to remove the outliers so that we cannot our model cannot overfit. For outlier removal, we are using interquartile range. So using the interquartile function, here I count the number of outliers present in the each every date. So interquartile range means the quartile, the midline is about the median, and the below the midline, the starting line of is the quarter one, which is 25% of the data is lies within, and the median line is the 50%, and above that 50% line is the 75% quartile. So now using that basis, I have removed the outliers in each and every column, so that yeah, after removing the outliers, we can see that the visualization of the model. So here this value represents the median of the value, means 50% of the data. This is the 25% of the quartile, this is 70% of the uh, range, and this is the maximum value, and this is the minimum value. So categorical encoding. So we all the data here, we have the float type and the int type. So we need to do the categorical encoding here. The textual don't the textual data processing is for the NLP. So we don't require that now. The feature manipulation. So we have the temperature columns and the humidity columns on the outside. So we have to means mess up the columns so that we cannot maybe with these columns we can derive another type of column, so that can be more correlated or more influence the appliances energy consumption. Here are some average building temperature. So average means the total room numbers temperature mean by the number of size of the number of the rooms. Here gives temperature differences, means the average building temperature minus outside the building temperature gives us the temperature. We are given absolute function so that we only have the positive values. The same goes with the humidity columns as well. So feature selection. So the random one, random two variables are no much important to software data. So we are dropping the random variables 1 and 2. So checking multicolority. So we are discussed in the EDO part. So much multicolority is present within the variables as the temperature within the temperature columns itself, and the humidity columns itself, and between the temperature and humidity column also. So with the VIF factor, we are now can be taken care of the multicollinearity within the variables. So here gives us the, we have variables with the VI factor infinity. So there are highly correlated with each other. So we are removing some of the columns. So as our appliances column is our dependent variable. So we are removing that column from our data. So we can calculate the VIF factor, VIF. So temperature question and the average building humidity temperature difference are they are correlation of multi-gonna have a high value of VIF factor, AF. So now we are removing the lights temperature question and all the things which are have the having the high uh, collinearity or VF number. So now after dropping those columns, we are remaining with the pressure, temperature, rooms, average building humidity, ironing room, outside humidity, and so on. No? So we can keep the VF factor less than 10 so that we can get into best fit model. So we are again doing the same procedure to till we get the VF factor less than 10 with the columns VF less than 10. Here, uh, and finally we got the uh, variables that are more less collinear and the more influence factors so that we can predict the appliances energy. So we have some of the columns are humidity differences, humidity building out. So humidity differences which come up with the average of the humidity of the whole building and the humidity outside. So these two, okay, these two have means same value or same multi collinearity. So again, now we can check the multi-polarity once again. So wait a minute. Now we can check the correlation with the, mm, so the final five columns is humidity building out, wind speed, dew point, month, weekday, and hour, humidity difference. So these two five variables are much influence means we have uh, less we have factor less than 10 so that we can uh, go ahead with these variables. So to implement the model. So data transformation, as we said, if we have skewness in our data, that may lead into the overfit. So we have to deal with the skewness of the data. So to run the model or to implement the model, here appliances has as we said, it is not following, is rightly skewed. And the wind speed also have the rightly skewed. Okay. So here we can see the way appliances has the eye positively skewed and the wind speed also is the more likely to 79 0.7, and that is It's more moderately skewed. So we have to apply the log transformation so that they can follow the normal distribution. After all, this coming to the scaling part. So I have applied Vmax scaler to our test data and the train data. So as our data is ready for the model practice or the model implementation, so we have split the data into the two parts, train part and the test part. Daddy, daddy up. Abbo, abbo. ఎందుకు వచ్చారు వెళ్ళండి అసలు train data into the test data. So we can see the shape of the data. We have 19 7 features or the 7 variables. One is the so these are all the features that we are trained the data into predicting the model. And here is the y, that is the dependent variable appliances. So here we split the data into the train and the test data. So X-train I define with 80% of the data is to be in the test data, train data, and the 20% of the data is the test data. For the scaling part, we have implemented the min-max scaler on the test data and the train data as well. We don't need the dimensionality reduction in our data. So coming to the ML model implementation, first we have done with the linear regression model from the scikit-learn library, from scikit-learn.linear model import linear regression. So in the linear regression, we have fit the data, fit the train data and the X-train scaled and the Y-train data. So using that train data, we predict the Y-train means uh, which we are predicting the uh, predicting the y means independent dependent variable using our x train data. So here y prediction is the prediction data using the test data. So here is the y prediction using train data and y prediction using the test data. So mean square error is the error between the uh, test data and the actual data. So here we can see the difference means we can see the numbers again, the R2 score and the mean square error. Mean square error and the R2 score is the best matrices in the linear regression model to check our model is performing better in the mean square error. It has to be a very minimum in the mean square error case, and the R2 score it has to be a maximum. Now we applied the ridge regression and the last regression from the cycle using the scikit-learn model into what the lasso and the ridge regression. So here we can see the scores of the models using mean square error is 0.039 in the case of linear regression model. And the R2 score is very low, which means our model is our data is not fitting means predicting the actual value means 0.16. Though since the three models of performance is very low compared, we can visualize this through the data. So here the actual ones are the orange ones, and we can see the blue ones. So our data has been predicted the values very low, means uh, they are not very near to the actual values as well. So there is so much of error being between the predicted value and the actual value. So here we come with the coefficient of the regression, means beta 1, beta 2, the beta naught of the values of the model coefficients. So we can see the means comparison of the uh, model performance. So is the red line represent the actual model, means actual data points are the actual energy consumption of the appliances, and the green ones represent the ridge. So here we can see that the ridge has been more comparatively good, means it is not the best fit model, though the lasso is been very bad. So we are not get predicted with the means we not choose the parameter, means precise hyperparameter or alpha value for the train data scaling of the data performance for implementation purpose. So we are through the grid search to predict the best parameters that can be applied on the model to fit the data and to get the maximum R2 score at the best fit model. So we are applying the grid search among the ridge regression and the lasso regression uh, within the specified parameters. So as well as upon performing the grid search and CV search, we are also implementing the same in the model, fitting the model using the CV and lasso CV. So within the predicted parameters, the model itself fit the data into using the predicted model and give the best performance model at the best R2 score and the mean square meanwhile. So as you see, ridge regression best alpha value is 5 and the mean square is not changed, means there is no much significant increment in the model, though there is slightly increment in the model. So best alpha is to be 0.001. The mean square is the same as is discussed above. So we are saving the means the data, means the values that we are getting in the data frame, so that we can be visualized or we can be analyzed to get the a good fit model. So using the both applying the lasso and the regression, we can implement the elastic net model to predict fit our data to train our model to get the accurate good fit model. So here on applying the elastic net model or fitting the data into the elastic model, we can predict the Y prediction. So here we can see the mean square is about 1963. And the R2 score is very low, means it is -2. So this is not very good model to predict our appliances energy data. We can see visualize this, so it is not much very near to predicting our data also. So on applying the cross validation parameter also, we are not getting. So if model somehow implemented, the error got reduced, mean square is reduced by 200. And the model is better performed from the previous one. We can see the score test to score is the same among the three regression models. So finally, we are implementing the decision tree regression with the random state of 42 equal to 42. So here we can expect the good performance from the model. So here we get the mean square to be 0.022, very, very less. So the R square score is the 52, which is way more better than the previous models. So we can simply visualize the true within the true values and the prediction values. So it can linearly, we can see that it is very accurately fitting between the data. So we can see the legend plot also. So it is more nearly approximating our predicting our values to actually with minimum error. So we can perform better tuning with the cross validation, grid search CV, grid search cross validation parameter with the use of in the dish tree regressor. So we can implement our model. So implementing that, we have uh, got the best parameters as minimum sample if is 8 and minimum sample split is 20. With applying these parameters in our model, so we are reducing the error into the 0.019, which is less than the previous model, and we have improved our R2 score. The same can be adjusted in the data frame, scored data frame. Uh, from the last regression, means extra T regression is also implemented using the extra T regression method, which is random state 42. Here we can see that the minimum error is, the mean square error is so minimum. The R2 square is far better than the other previous models, which is 73%, which is good to predict our model and implement our model. So we can see that the data points are highly fit into this regression model. So on applying grid search CV, we can compare the best parameters for the tree regressor, extra tree regressor. The R square about to be 73%, which is best suited for our model. So I think this extra tree regressor outperformed along on among the previous models, means linear regression model, ridge and lasso and decision tree. So I think the best model is to implement the model is extra tree regression as of now. So we can compare the mean square score results and the R2 score results. In the mean square errors to be minimum, the extra tree regression, the mean square is very low compared to the others, and the R2 score is very high for the extra tree regression in the uh, model. So as per conclusion, uh, as the appliances energy consumption is uh, critical to save the energy in our household purposes. So we have to collect the data from the sensors. So we can see that the appliances energy consumption is most influenced by the dew point temperature and the outside wind speed and the outside pressure also. So humidity also. So these are the factors are mainly outside the building. So we can implement the IoT system so that we can uh, get the data from the outside, and according to that we can uh, with the IoT, with the help of IoT, we can cut off the energy consumption in the household, so we can save the energy. In the data, we have so many outliers is there. We have performed using the interquartile range, and there is multicolarities within the data. We have deal with the multicolarity using the way we have factor various variance inflation factor. So we have dropped them. And for implementation purpose, we have implemented linear regression, lasso regression, ridge regression, decision tree, elastic, and extra tree regression to predict the household appliance energy consumption. Among all those, I conclude that extra tree regressor was discovered to be the best performing model with the R square value of 73%. So here is the my machine learning capstone project using the linear regression to predict the appliances energy consumption. So, so did I well, and my thank you to my fellow teammates Abhitendu to help me to complete the process, and for the Alma Better team, the mentors and the lecturers to better understanding these concepts to clear uh, better understanding of the linear regression and model implementation to help me with to do this project. Thank you.